In this video, we'll discuss the zeros of polynomial functions. The zeros of polynomial functions are known as the roots, or solutions, when f of x equals 0. Each real root appears as an x-intercept of the graph. So, for example, f of x equals x cubed plus 3x squared minus x minus 3. Since the zeros are the values of x when f of x is equal to 0, we set f of x equal to 0. We solve the polynomial. X cubed plus 3x squared minus x minus 3 equals 0. First, we're going to factor x squared from the first two terms and negative 1 from the last two terms. A common factor of x plus 3 is factored from the expression. So then we set each factor equal to 0. X plus 3 equals 0, or x squared minus 1 equals 0. Then we solve for x. X equals negative 3, x squared equals 1, so x equals plus or minus 1. So the zeros of this polynomial are negative 3, negative 1, and 1. Multiplicities of zeros. For f of x equals negative x squared times x minus 2 squared. First, you're going to find the zeros of this function. So we will set this function equal to 0. Negative x squared times x minus 2 squared equals 0. Then we will break each apart. Negative x squared equals 0, x minus 2 squared equals 0. We got rid of the negative on the left and got rid of the square on the right, so therefore x equals 0 and x equals 2. When looking at these two factors, we must notice that each factor, negative x squared and x minus 2 squared, occurs twice. So therefore, the zeros are 0 and 2 with multiplicity of 2. Now we will discuss some key things about graphing when dealing with multiplicities. If r is a 0 of even multiplicity, then the graph touches the x-axis and turns around. If r is a 0 of odd multiplicity, then the graph crosses the x-axis. For example, if a function has zeros 4 and 6 with multiplicity 2, then the graph touches the x-axis at 4 and 6. If a function has zeros 4 and 6 with multiplicity 3, then the graph crosses the x-axis at 4 and 6.